chapter 7, which is rational algebraic functions. So now let's discuss the first section, product and quotients of rational expressions. And I'll give you some examples how to solve problems in this section. But before that, let me just emphasize about factoring and the cancelling. So whenever we have rational algebraic function and we have exactly the same factors like this, okay, exactly the same, therefore we can cancel that and it becomes 1. Okay, the thing is, if I have vectors like this and this one on the denominator, you need to know that actually it's just the same with this. This one is the same with this, since we are using the axiom of commutativity for addition. That's why you still can cancel it. It is 1. Okay, and the next one, if I have x minus 3, for example, over x minus 3, okay, so it's exactly the same, therefore it is 1. But if the last one, if I have x minus y and then over x plus y, these two are totally different. So you cannot do anything with this. You cannot simplify it, you cannot cancel it, so you just accept that the way it is. But the last one is, how about this one, x minus y over y minus x. Okay, notice that actually they are not the same. Okay, since the axiom is not for subtraction, so it is totally not the same. Okay, but if I factor out, let me just example this. If I factor out -1 from y minus x, therefore I divide y by -1, it becomes -y, and then I divide -x by -1, so it is plus x. So it will be the same with -1 x times x minus y. Therefore, if I erase this one, okay, draw. So here's the one of the key point that I want to introduce. So x minus y over y minus x, you can convert y minus x into -1 multiplied by x minus y. Okay, again, this one is the same with this, but don't forget you need to multiply it by -1. Therefore, I have exactly the same factor on the denominator and numerator, so I can cancel it. So the final answer is -1. Okay, so please notice if we have specifically this situation, you have -1. So the conclusion is, if I have exactly the same, x plus 3 over 3 plus x, okay, it can be cancelled. Okay, and if I have x minus 5 over x minus 5, it can be cancelled. It will be 1. It will be 1. If I have x minus 7 over 7 minus x, it means I have to convert the order, at least one of it. I choose the denominator, so if I subtract or factor out -1 from the denominator, it will be x minus 7, right? So I can cancel it, so it becomes -1. Okay, therefore, quickly, if you practice a lot, so you can be aware that this one is it's -1, sorry, and then yeah, any kind of yeah, you can be aware of any kind of the same situation. It will be -1, or maybe 7 minus a over a minus 7, it will be -1. But if it is a plus 7 over 7 plus a, of course it's 1, because they are exactly the same. The first problem that we will discuss is from page 361, number 29, and this is the problem. So you need to first multiply it and then you simplify. Okay, so let me just start with factoring. Okay, let's just factor everything that we can factor. First, I can factor this one, right? This one is x minus 1 multiplied by x squared plus x plus 1. And then over this one, x plus 1 is already been factored completely, multiplied by this one is factorable, which is x plus 1 multiplied by x plus 1 over, now this one, of course, if you are not sure, you can use the discriminant to find whether it is a perfect square or not. And find if it is a perfect square, it means it's factorable. But if it is not, it means you just need to stop and just write that one, that polynomial, which is actually, if you find discriminant, it is negative, so it's not factorable. So after you have factored completely all of the elements, all of the polynomials there, then let's try to simplify. So we can cancel this one, we can cancel this one, and the one that being left is x minus 1 times x plus 1. So in the end, your final answer is x squared minus 1. This time we have division. Okay? So the first polynomial divided by the second rational expression. So the first thing that we need to do is to convert all of this into multiplication, okay, to make it simpler. So let me just copy the first rational expressions, which is x squared minus y squared. But rather than we use division, let's convert into multiplication. Okay, this is multiplication. Let's just say this is multiplied by y minus x over y plus x. That's the first thing. And then let's just factor everything, each of the numerator and denominator. For the first one, it's factorable, so it is x plus y times x plus y, okay, over x plus y times x minus y, multiplied by, let me change it. This one is negative 1 multiplied by x minus y, over, this one is x plus y, because y plus x and x plus y is exactly the same. Now we can start canceling, right? So this one being cancelled, this one being cancelled, this one being cancelled. Wow! So it's negative 1, the final answer. So don't forget, the difference of multiplication and the division is just like you need to change first, to transform first into from the divisions into multiplication. Okay, so be careful with this. The next one, okay, I will give you two more examples. The next one, this one. So let me just, this is multiplication. So let me just factor everything completely. And let me just write down here, if I have 3x squared minus 2xy plus 6x minus 4y, okay, this is like 4 terms. Therefore, we can try this approach first. Collect the first 2 terms and the last 2 terms and factor out the same element. And for this one, I have x, right, multiplied by 3x minus 2y. And from the last 2 terms, I can factor out 2 multiplied by 3x minus 2y. Therefore, the factor is x plus 2 multiplied by 3x minus 2y. Okay, so let's just do that. So the first polynomials on the numerator can be factored out to be x plus 2, and then this one is 3x minus 2y over, okay, this one, let me just use splitting middle terms. So this is 3x squared plus xy minus 2y squared. So I can split the middle terms into 3x squared plus something xy plus something xy minus 2y squared, which that something and something, if you multiply, it has to be negative 6. If you add, it has to be 1. So the combinations that can fulfill this or satisfy that will be 3 and negative 2, right? So this is 3, this is negative 2. So in the end, I can collect the first 2 terms and the last 2 terms and factor something out. So I will factor out 3x. This one will be x plus y. And this one I will factor out negative 2y. Negative 2y. And the one that being left is x plus y also. So in the end, the factor is 3x minus 2y multiplied by x plus y. So this one, let me just copy it. This is x plus y. I put here x plus y. 3x minus 2y. multiplied by x minus 2 cannot be factorable further, and this one is x plus 2, x minus 2. So after we have factored completely all of the numerator and denominator, we can start simplifying. So this one can be cancelled, and then this one can be cancelled, and this one can be cancelled, and in the end the final answer is 1 over x plus y. So the key point is factoring completely. You need to factor all of that correctly so you can simplify it. And the simplifying and cancelling is the easy task. Okay. And how about this one? So for this one, I want you to carefully read your textbook, page 365. So I put it here, page 365. Okay, carefully. I'll give you one example, okay, but different with the examples that being shown by the textbook. So for that example on the textbook, page 365, I want you to read carefully, okay, and master it. I don't want to explain that one. So let me just use the same technique for this case. So since we have a division, actually this is the division, since we have this one, divide by this one, right? So let me just go to copy this one first, minus x squared minus 5x plus x minus 3 divide by x plus 3x over x minus 3. So let's just get rid the denominator in the numerator and the denominator. So let me just multiply the whole thing with x minus 3 and multiply it by x minus 3. Can we do that? Of course we can do that, because actually we multiplied with x minus 3 over x minus 3, which is 1. So whenever you multiply by 1, which is a division of two exactly the same values, it will be safe enough. Okay, but don't forget, you cannot just multiply one numerator by x minus 3 and then the denominator with the other thing, for example x plus 3 or none. It will be false. It will be a mistake, since you are multiplying with a number, not 1. So as long as we do this, it's safe, because x minus 3 and x minus 3 can be cancelled. So we don't change the value. We don't change anything here. Therefore, what is the objective of multiplying this? So if I multiply the whole thing by x minus 3, I can have, with the distribution axiom, x multiplied by x minus 3, look at it, I distribute it, minus 2 multiplied by x minus 3, right? And then minus x squared minus 5x, right? Why? Because when I multiply x minus 3 into this fraction, I cancel the denominator and that factor, x minus 3. Therefore, it's just the numerator that being left. Okay, I hope that you can see the point here. So over, okay, this one is x multiplied by x minus 3 plus 3x. So yeah, we have simpler situation here. We have simpler. So let me just distribute everything. It will be x squared minus 3x, x squared minus 3x, minus 2x plus 6, minus 2x plus 6, minus x squared plus 5x over, this one is x squared minus 3x plus 3x. Can we still simplify it? Of course. This one is gone, x squared minus x squared, and then minus, okay, this one is gone, and the one that being left is 6 only on the numerator, and this one gone, so it's 6 over x squared. And this is the simplest form that you can get. Therefore, done. It's quite easy. We just have the delicate problems at the beginning. So if this is the case, since I want to get rid of the fractions inside the denominator and numerator, of course I can multiply it with 1, but the biggest mistake is if you try to multiply the numerator by x plus 1 and the denominator by x minus 1, which is you are changing the value. You cannot do that. Okay, that's why we only can multiply it by x plus 1 over x plus 1. But see, if I multiply x plus 1 to the numerator, yes, it will eliminate this one. But if I multiply x plus 1 into the denominator, it won't eliminate x minus 1, right? It won't cancel it. You won't get rid the fraction there. So what we can do is, since we can only multiply it by 1, I multiplied the whole thing by x plus 1 and x minus 1. X plus 1, x minus 1. Okay. Therefore, if I multiply this into, so I will have x plus 1, x minus 1, which is I multiply first by 1, minus, okay, let me just show you. I multiply x plus 1, x minus 1 into that. Okay, over, this one will be x plus 1, x minus 1, multiplied, and minus 2 over x minus 1, multiplied by x plus 1, x minus 1, right? So you can cancel. So in the end, I can have a simplified one, which is x squared minus 1. This is x squared minus 1, right? Minus 4 times x minus 1 over x squared minus 1 minus 2 times x plus 1. And in the end, I have, this one is x squared minus 1 minus 4x plus 4 over x squared minus 1 minus 2x minus 2. It will be x squared minus 4x plus 3 over x squared minus 2x minus 3. So the question is, can we factor the numerator and denominator? Since we need to simplify, and yes, we can. So it is x minus 3, x minus 1 over, this one is x minus 3, x plus 1. Oh, we can cancel this one. So the last answer will be x minus 1 over x plus 1, since we cannot cancel x minus 1 with x plus 1. So that's how you do this kind of problems. Well, of course, you notice that you have other options how to solve this one. Since you know that 1 plus 1 over 4, for example, you can solve it with converting 1 into 4 over 4 plus 1 over 4. So you have two fractions with the same denominator. It is 5 over 4, right? So with the same concept, we try to convert 1 into x plus 1 over x plus 1 minus 4 over x plus 1 over this one. I use x minus 1 over x minus 1 minus 2 over x minus 1. So in the end, I have x plus 1 minus 4 over x plus 1 divided by x minus 1 minus 2 over x minus 1. Since we are talking about division, therefore, and I simplify everything, it is x minus 3 over x plus 1 divided by x minus 3 over x minus 1. So since we are talking about division, let me just look at that. So I can change it into multiplication, which is x minus 1 over x minus 3. Okay, this is division, this is multiplication. So I can notice that actually I can cancel x minus 3, since it's, so the last answer is x minus 1 over x plus 1. So yeah, this is simpler. So you can choose either way.